Hello everyone, my name is Merkle Tree, and today I will be explaining one of the most important data structure used in blockchain technology, the Merkle Tree. We'll look at what it is, why it works, why it is important, and where it is used. A Merkle Tree, also called the hash tree, is a tree-like data structure used in blockchain to organize and verify large amount of data efficiently. So instead of checking every transaction individually, a blockchain can verify whether a transaction exists by checking only a small number of hashes. So this concept was invented by Ralph Merkle in 1979. So what is really hashing? Hashing is the process of taking any data, such as a transaction, right, and using a hash function to convert it into a fixed length string of characters called a hash. Even a tiny change in the original data can cause a completely different hash, while making it useful for verifying data and detecting tampering. So why is hashing important? Hashing is important because it helps verify data integrity, detect tampering, and secure blockchain transaction. So how a Merkle tree works? So imagine we have a tree, right? A tree consists of the roots, the branches, and the leaves. Now turn the tree upside down, then we have a Merkle tree. So a Merkle tree consists of the Merkle roots, the parent node, which are the branches, and the leaf node, which are the leaf on the tree. But upside down, that is the Merkle tree. So a leaf node, the leaf node, imagine we have transaction A, B, C, D. So transaction A, B, C, D hashed will give us hash A, B, C, D. Those are the leaf node. So how parent node works now? We have hash A, B, C, D. Those are the leaf nodes. So to get a parent node, we concatenate hash A with the neighboring node, which is B. So we have hash AB. The same goes for C. We concatenate with the neighboring node, which is CD. So we have hash CD. So hash AB is a parent node. Now hash CD is also a parent node. So we've talked about the leaf node, the parent node. Now the Merkle root. So we concatenate parents A, B together with CD to have just one more hash. So we pair them to one hash remain, which is the Merkle root. So remember we have parents A, B and parent CD. So we concatenate both neighboring together to make hash A, B, C, D, which is the Merkle root. In a case where we have multiple transactions that are odd, so remember we have transaction A, B, C, D before as our example. Now imagine we have transaction E join. So we can't pair E with anybody again since we have A, B, C, D. So now in a case where we have E, we will duplicate E. So we have transaction A, B, C, D, then E. So AB, hash AB will give us parent node hash AB. Then hash CD will give us parent node of hash CD. Then hash EE will give us parent node of hash EE. You get? So then we also do the same thing to the Merkle root, which is going to be the last hash. So we now have hash, that would Merkle root hash A, B, C, D, E, E. Why Merkle tree are important? Merkle tree are important for fast verification. So instead of checking the 1,000 transactions, only a few hashes need to be checked. 2. Data tampering. If anyone changes one transaction, it changes the hash. 3. Improve efficiency. Merkle trees make block verification much faster and reduce the amount of data that needs to be transmitted. So we also have the Merkle Proof. So suppose you want to check if a transaction C exists in the block. You don't need to take the whole tree. You just need hash A, B, and hash D and the Merkle roots. From these hashes, you can recompute the path to the Merkle roots and verify that transaction C exists in the block. This is called a Merkle Proof. So in conclusion, the Merkle tree plays a vital role in blockchain technology. By organizing transaction hashes into a tree structure, it allows transactions to be verified quickly, detects any change in data, and helps keep the blockchain secure and efficient. So I hope this video helped you understand what the Merkle tree is, how it works, and why it's so important in blockchain. Thank you for watching. Don't forget to like, share, and subscribe if you find the video helpful. Thank you.